Welcome everyone. This is session 1B in Stormwater Awareness Week. Today's topic is addressing 6-PPD and 6-PPD quinone, turning science into policy. We have our speakers today are Tanya Williams, 6-PPD lead agency planner and tribal liaison in the hazardous waste and toxics reduction. And we also have Shelby Glittner, 6-PPD stormwater engineer, who they're both going to present the latest policy actions on 6-PPDQ and its implications for stormwater management. And we'll follow it up with a Q&A session at the end. So just a reminder, this session is being recorded and it will be available on YouTube with the link in the chat if you want to follow that. And yeah, we're just going to get started. So go ahead, Tanya, take it away.
All right, thanks, Stephanie, and thanks for the invite. This is my first time participating in Stormwater Awareness Week, so this is exciting. And as Stephanie said, I've been leading 6PPD at the agency for about 3 years now. And today we're going to reframe a little bit in how we present. I know a few of you have probably heard our team present on 6PPD and 6PPD quinone. Over the last couple of years, some of you might be very deeply engaged in some of the research and some of the policy and helping to support planning and next steps, which is fantastic. I recognize a few of you on the call. And so I'm going to go a little bit backwards just to make sure we frame this up. I know that I learn about folks every day that have not heard of 6PPD yet. So bear with me as we step through that. And then we're going to go into some stormwater specific stuff because that's what I think a lot of you are interested in. And Shelby will jump into that here in just a little bit. So we do want to highlight Rhea Smith. I know some of you work with Rhea very closely. We're going to talk a little bit about her work today as well. She is our lead monitoring strategist for 6-PPD quinone and is not here, but is a really integral part of our team in moving the work forward. We're going to look at alternatives work briefly, mapping and monitoring, and then Shelby will talk about stormwater. And then we're also going to talk about some next steps. And I was glad to see that Stephanie had a bunch of QR codes up. We are going to be very QR code heavy as well, because we want to make sure you have links to the resources that are available to you today while we continue to look at research. So let's talk about what's been going on. So 5-year anniversary, which is pretty astounding when you think about how much work has been done over 5 years. It seems slow, but really in the history of chemicals and discovery, it is quite fast. So just to move backwards a little bit, you'll notice University of Washington, Tacoma, Center of Urban Waters, and then the WSU, Washington Stormwater symbols up there, their icons, and that's because they were really instrumental in the discovery of 6-PPD quinone. They started looking very specifically at the chemical. This does not include the decades that they were looking at the stormwater and what could be causing mortality in coho. But they started in 2018 and looking at tire wear leachate and found over 2,000 chemicals in that leachate mixture using high resolution mass spectrometry, eventually fractionated down to 6-PPD quinone discovery. So it's something to keep in mind. We're about 5 years into the discovery of 6-PPD quinone. And again, 6-PPD quinone is not intentionally added to tires. That chemical is called 6-PPD. Some people like to call it the parent compound, but it is the anti-ozonate that is added to the tire to prevent it from cracking and degrading. It binds with ozone. And I see the chat popping up. Okay, great. Thanks, Jason. I thought that might be a question for me. And binds with ozone. And when it binds with ozone, which is designed to do, because that's how it protects it from ozone degradation, it produces a chemical called 6-PPD quinone, which is what was the chemical discovered 5 years ago. Both are continually emitted when you're driving your car in tire and road wear particles, and thus are globally contaminating. And because we have tires everywhere, it's consumed to be in all tires around the globe because it is a superior anti-ozonate. And of course, the discovery back in 2020, end of 2020, was because 6-PPD quinone was so acutely toxic to coho salmon As they were swimming up their natal streams to spawn, they were finding them with their eggs still in their carcass after they had died, which was a big concern. And they've been seeing this for quite some time, just without a chemical to point to. And since that discovery 5 years ago, a lot of work has been going on. We now know that 6-ppd quinone is also toxic to coastal cutthroat trout at a level that is quite similar to coho, which was a unique discovery for 6-ppd quinone, because most of the species we had been testing, even if they were closely related to coho salmon, within the salmon phylogeny tree, were not as sensitive. Some of them so much so that they experienced no symptoms, sublethal or observational or lethal. And you'll see there that rainbow trout and its brethren stillhead, and then also brook trout and lake trout are showing sensitivities as well at concentrations that we see in the environment at times. So more research is still being done on other species. Back when 6-ppd quinone was discovered, there was an individual at the Washington State Department of Ecology that was very closely involved with the Interstate Technology and Regulatory Council. That is a nationally run group that breaks down state barriers and identifies opportunities for collaboration and solving problems and helping to share research and share expertise so that everybody's not always starting at ground zero with approaches to finding solutions. They proposed a team on 6-ppd to this group. It was accepted. The team ran for 2 years and was quite unique because it was a team of researchers that had just started working on 6-ppd and 6-ppd quinone. We had the tire industry involved, and they produced this guidance document. It was really the first of its kind in the world that collated and synthesized all of the research that had been done to date. We just gave our very last training using this guidance document yesterday morning, but that QR code will take you to that resource. And it really is a good tool. Keep in mind that it's about a year and a few months old now. And there's been a lot of research come out to date since that was put in place, but it still has a good framework for you to learn from. Next up, during this process, Rhea Smith at the Department of Ecology put together one of the first mapping tools to try to identify hotspots for people to start looking at and people to start better understanding where might 6-ppd quinone be a problem for sensitive species. And this is still available online. Since then, USGS has released some nationwide mapping efforts to help people understand 6-ppd quinone hotspots. And there's still a lot of work being done on these maps in order to validate them. So people are going out and sampling and confirming some of the assumptions on concentration within these mapping profiles. They take into account a lot of things, not just traffic, impervious surface, et cetera, and then also location of sensitive species in order to identify those hotspots. We also produced a 6-ppd action plan. We had an advisory committee made up of over 50 individuals in order to step into the direction we needed to take this current biennium, which we're going to talk about here in a little bit. But that is still available online. A lot of folks are using that action plan and the recommendations identified in there in order to plan their work for this biennium, in order to identify data gaps and research needs that have been identified when they're planning their proposals for funding opportunities, et cetera. So that is online. We submitted a report to the legislature in December of 2024 that was a high-level overview of this effort and helped to guide the budget package that we asked for this biennium. And that was across not just ecology, that was Department of Fish and Wildlife, DNR, Department of Health, et cetera, all engaged on that and used it for their funding package. This is so close to being issued. I wish I had a QR code that would bring you to this report. But in the supplemental budget last year, there was directive to the Department of Ecology, specifically our solid waste program, to perform a used tire assessment and look at all the ways that Washington was recycling and using spent tires, And this report, that QR code is going to bring you to a presentation that was done recently. But stay tuned. Any day now, we will release the final report. It's going through final reviews at Ecology, and we will push that out in our 6PPD email list. And if you're not part of that, we have a QR code for you for that as well at the very end of this presentation. But it's eventually going to also look at communities that are maybe disproportionately impacted by recycled tires, and whether we need to start looking at restrictions potentially for recycled products, depending on where they're being reapplied, and whether we need to be looking at waterways that might have recycled products a little bit too closely applied, depending on whether we're finding issues with those products. So stay tuned for that. And then also I wanted to have you take a look back at federal action. Right now, there's not a lot occurring due to the shutdown and the current political state. However, our federal partners, predominantly USGS, NOAA, and EPA, have been very closely involved in this since the discovery of 6-PPD quinone. And as a reminder, there was a petition that was filed by 3 tribes, the Port Gamble S'Klallam tribe, the Puyallup tribe of Indians, and then the Yurok tribe out of Northern California, got together and filed a petition to prohibit the use of 6-PPD in tires under EPA's TSCA, so Toxic Substances Control Act. EPA granted the petition a few months later, and then they did declare that they would issue an advance notice of proposed rulemaking that basically laid out all the steps that they would take in order to properly assess and determine next steps for 6-PPD under TSCA. They did issue that in fall of 2024, and then also issued a notification of collecting information from 6-PPD manufacturers so that they could get all of the toxicity, data uses, etc. And they just officially, 4 months ago now, delayed that information gathering. So we're waiting to hear on next steps there. But this is at least a background that where the federal government is at. And I did see a comment pop up, and I can't see them right now because the way Zoom shares PowerPoint, but you are more than welcome to pop on and ask it, or I can try to minimize, or maybe Shelby, you can pop on and tell me what the question.
I can read it to you.
Okay, thank you.
The question is there a good alternative to 6-PPD that prevents cracking without the harm? And I was going to say, we might have a more of a discussion at the end. So I'll leave it up to you, Tanya, if you want to address them as you go, or if you want to save them till the end.
The next slide is safer alternatives, so I might answer that question here in about 2 slides. And then, if there's any follow-up, I'm definitely available to do that.
Okay, and if I see anything else in the chat, I might just ping you.
Oh, totally fine. Interrupt me anytime.
Okay, thanks.
Oh, yeah. So that all being said, we're going into the new biennium. So we have Ecology having worked on 6-PPD quinone for about 5 years. And over the next couple of years, this is what the legislature directed us to do. Unfortunately, some of this funding is MOTCA funding. And if you're aware of Washington State's budget shortfalls, that funding is impacted. But we do have a secured stormwater best management practice research funding bucket that Shelby's going to talk about. And then we also are able to continue some of our alternatives research and our monitoring. So let's go into a little bit of science to policy sort of work. And one of the areas that we have been working on since the discovery of 6-PPD quinone is assessing safer alternatives. So getting to the question just in the chat. One of the first things that we did was set hazard criteria. So what does safer mean? What do we have to assess in order to decide that an alternative is safer? So a couple of years ago, we issued some hazard criteria, and this was based on our Safer Products for Washington program's hazard criteria. But 6-PPD, the parent compound, is what we're looking to replace, right? And we're looking for alternatives for. And 6-PPD in and of itself is already highly toxic, but it was put into manufacturing back in the 50s. So there weren't really any requirements to look at toxicity back then. So it's, what one might call a grandfathered chemical, but it would not actually meet our safer products for Washington criteria. And then when you look at ozonating 6-ppd into 6-ppd quinone and its slurry, it's even more acutely toxic. So we needed to take both of those into account as we're trying to look for alternatives. And that included testing not only coho, because coho are the species that are showing great sensitivity to 6-ppd quinone. We did not know about coastal cutthroat trout at the time that we set the criteria, but it'll be interesting to see if we eventually, we see people submitting data for that as well. Rainbow trout, and then we're also looking at lampreys, mussels, or other food chain levels. So the criteria says 3 trophic levels. So what that means, it's pretty flexible. And then they also need to ozonate the parent chemical that they're looking at. And I'm going to show you a list of parent chemicals and talk a little bit more about performance in a second. But they need to ozonate it. We're not asking them to identify specific contaminants in the ozonated mixture. So if you take 6-ppd and ozonate it, we all know the 6-ppd quinone is produced. But we're asking them to look at toxicity of the entire slurry instead of having to fractionate out and determine the constituents in the mixture. And so that is set. And so that's what chemical manufacturers are using, that and then ECA's rules as well in order to look at European standards. So chemical manufacturers that are looking for a safer alternative are using both our hazard criteria and ECA's in order to do their testing. And there are people running testing. But we are also doing some testing in Washington because we're responsible for writing the alternatives assessment within Washington state. So we've been looking at CCPD, 77PD, 7PPD, IPPD, and Durazone 37, and a few others that people have brought up to us. These ones were all ones that we had identified very early on. They're currently manufactured. They're currently an antioxidant. Some of them used before 6-ppd entire. Some of them used before 6-ppd was developed and manufactured. Some of them used in conjunction with 6-ppd and have different functions within the tire. And so in order to eliminate these as possibilities or bring them up as possibilities for alternatives, we are running some of our own toxicity testing. A lot of those results are starting to come in. But as the individual who, I apologize, I can't see it, commented in the chat, was about performance and understanding that whatever alternative is identified as being safer from a toxicity standpoint also has to perform in the tire and do what 6-ppd does in the tire, which is quite a bit. It is quite a superior compound, and it is difficult to find an alternative. And as you can see in that picture there in front of you, that the one on the left is 7-ppd and the one on the right is IPPD. 7-ppd clearly does not perform well in rubber, but IPP does. Now, the next step would be, since we have the chemical industry and the rubber manufacturers and the tire industry really being the lead on a lot of this, is, well, what does IPPD do in the tire? And what does it not do that 6-ppd does? Because there's a lot of unique behaviors that 6-ppd has, like it doesn't bind to anything else and it moves very freely, and it provides that flexing that we expect in the rubber matrix and need in the rubber matrix in order to have a safe tire. So stay tuned on this. We post all of our research on our website as the reports come in and are cleared. And we've got one coming up from USGS here soon that's looking at toxicity of several of these alternatives on coho and rainbow trout. And then we have a mussel study that's supposed to be kicking off with USGS as well to look at toxicity of all of these alternatives as well on mussels. And then we have some hyalella, some daphnia going on. And then from there, we're really watching and waiting and learning from the chemical industry on what they're finding and better understanding how we need to fill out our alternatives assessment moving into the next year. Lamprey, you'll see in that bottom, that is not something we funded yet, but something that we know is a data gap and a culturally significant species here in the Pacific Northwest, and we would really like to see somebody take on lamprey, and toxicity are the alternatives. So next up, artificial turf runoff study. So something else that we are working on in terms of identifying some safer products and materials besides just 6-ppd in tires is looking at the recycled products. And one of the ones that we brought up into the Safer Products for Washington program is artificial turf and the recycled rubber in there. And something we're looking at right away is alternatives to using recycled crumb rubber, as people like to call the infills. It's, termed crumb rubber. And there's cork, there's different shell materials, and we have a sampling campaign going on right now. I believe we've got 85 fields across Washington state. They're going to say that on and we're going to be sampling the fields and looking at 6-ppd quinone and opportunistically looking at PFAS, because PFAS is a known component of the blades of grass, and looking at the stormwater leachate. And then also we're looking at the products themselves and against their age and the weathering of them to determine whether we can identify some safer alternatives to using crumb rubber. And all of this will eventually end up in the Safer Products for Washington program within their second cycle, which is where we're taking on 6-ppd in tires and 6-ppd in artificial turf. And this is Ecology's rulemaking arm for chemicals and products, and a place where we can restrict the use of chemicals and products if we find safer alternatives and identify some avenues to get some of these chemicals out of products. If we find safer, feasible, and available alternatives, and that's really important to focus on, especially when we're talking about tires, something that is really critical to passenger safety, is that these chemicals need to pass all of those. And feasible means, can the tire manufacturers procure them? Can they put them in the tire? Are they available? So this is a worldwide product. We can't put a restriction on a chemical and require an alternative if that alternative is not being manufactured at a quantity that allows all tire manufacturers to use it. So this one is going to take a little bit of time to understand how to deploy once we do find an alternative, which brings me to the last safer alternatives note, is that even once we do find an alternative to 6-ppd, it is going to take quite a while to get that out of tires and to roll that manufacturing over, not only because we all are driving with tires with 6-ppd and some of them might last a couple more years, but also just beefing up the manufacturing and the rollout of the new alternative might take a while. They're focusing on passenger tires first. There's the reason why the difference between the 10 and 15 years there is that the formulation of the rubber for the truck tires is going to take a little bit different approach, and they're going to focus on passenger tires first and then move into truck tires. And then also other products like we talked about, the crumb rubber, but some other products do contain 6-ppd, and whether we want to approach looking at safer alternatives for those if they do end up being a point of concern, like rubber hoses, gaskets, rubber floor mats, that sort of thing have all been known to have 6-ppd as well. And that is it for me. So I'm going to pass it off to Shelby Giltner, and she's going to run through mapping and monitoring in stormwater. So Shelby, just let me know when you want me to advance.
Absolutely. Thank you, Tanya. And again, yes, I'm Shelby Giltner. I'm an environmental engineer with Ecology's water quality program. I focus on stormwater BMP effectiveness studies, but before I head into that, I'm going to cover Ecology's mapping and monitoring efforts, and this is to support our stormwater planning. This work is led by our environmental assessment program, very specifically Rhea Smith, who was one of the first scientists really in the country to start doing status and trends work on 6-ppdq in receiving waters. So one of the first efforts, again, we had this new chemical. We don't have standard operating procedures for how to sample, what to sample with, how do we catch peak concentrations. We have very limited analytical analysis. So one of the first things that Rhea and her team started to do was they had to conduct a method comparison study for 6-ppd quinone. So they had to look at different type of sampling methodologies to determine what would be the most effective and consistent method for measuring 6-ppdq. They looked at grab samples, which was when you were storm sampling and you're doing grab samples for storm samples, you have to have a staff out on site and they are literally filling a glass bottle at certain time intervals over the duration of the storm. This can be a really effective method, but it can also be really, really easy to miss the peak 6-ppdq concentrations because again, you have to have staff on site. You're literally manually filling the bottle. So there's a lot of risk, especially when we weren't sure when the peak concentration of 6-ppdq was occurring during the duration of the storm. They also looked at autosamplers. Autosamplers are an effective method for stormwater sampling. This is a piece of equipment that's installed at a sampling site. It uses a pump to fill bottles at either a time or flow weighted interval during the duration of the storm. It doesn't require necessarily someone being on site to do stormwater sampling, but they are a very specific piece of equipment that can be costly that not everyone has access to. And you do have to have a certain training and expertise to run them. They're not like a set it and forget it. They do require monitoring even during the time of the storm when they're out there collecting samples. So they're not easily accessible to everyone or a large group of people who don't have this piece of equipment can't collect auto sampling data. Although auto samplers do tend to be the best at capturing peak pollutants. But again, they can be difficult to have access to those equipment and have people to operate them. They also looked at accumulative passive samplers, which provide a really great tool for detection. These samplers are set out in the receiving water, and instead of grabbing at an interval, the 6-ppdq absorbs to a different media that's in the passive samplers. There are different types of passive samplers. I'm not super familiar with them myself. I've never used one, but they sit out during the duration of the storm, and you get a slightly different result than you do from an auto sampler or a grab sample. You're getting a mass over time. So you have to do some back calculations to figure out the actual concentration, which is a mass over volume. But they're much more accessible, they're much more affordable, and they don't require quite as much training and expertise to deploy. So the first study was to really look at these different type of methodologies and determine what they wanted to use to conduct their stream surveys. And ultimately, they determined that all of these methods had pros and cons. But again, the passive samplers are more affordable, don't require as much technical training. The active samplers, the auto samplers are really the best approach. But again, those should really be reserved for more intensive studies because there's just not enough auto samplers or staff to operate them. Next slide. All right, so for Ray and her team, once they worked on their methodology on sampling, they did conduct an integrated watershed study. The objective of this study was to determine what is the peak 6-ppdq peak concentrations and how long does it persist in a typical small urban stream. So they collected stormwater samples at 4 sites along an urban stream. They used auto samplers for this particular project. That's a picture of it installed on the slide right there. And they collected samples every 2 hours for 24 hours at the start of the storm. So for a total of 12 samples. The stream itself had a mix of geographic type and geographic area. The upper watershed was surrounded by park areas. It was a low urban site, very little highway runoff, mostly residential. And then as you move downstream into the lower watershed, they were seeing more urban sites with more highway runoff, impervious surface, parking lots, and less vegetation around the stream site. And this study was collected in a small stream in Olympia. And next slide. This is an example of one of the 6-ppdq concentration peaks during a moderate storm event in December at this urban site. So this is really interesting data. As you can see down along the x-axis, we have elapsed time. That dotted line right there is our aquatics life criteria standard for 6-ppdq, which is 12 nanograms per liter. What we found is anything above this concentration of coho salmon are subjected to like a 3 to 4 hour pulse at concentrations above this range. range, we do see coho salmon mortality. So the peak concentration of 6 ppdq occurred at about 8 hours after the start of the storm, and we reached up to concentrations over 80 nanograms per liter. So it's really interesting to see from this first preliminary data how far after the start of the storm we're seeing the peak concentration, and how far along during the duration of storm we're seeing 6 ppdq above that aquatics life criteria for about 10 to 13 hours. So again, this was just the first site, first round of data, but the peak discharge isn't on this slide, so you aren't seeing the peak discharge of the storm, but it really presents, okay, how far after the start of the storm are we seeing elevated concentrations of 6 ppd quinone in receiving waters? Next slide. So this is the full data for the whole stream survey. Along the bottom, you can see you're moving from high urban commercial sites, so that was the lower watershed, up to that low urban site where it had residential areas with a riparian buffer. The 6 ppd quinone was detected at all 4 sites, and the max 6 ppd quinone concentration was 500 nanograms per liter at the downstream urban site. So that had the most impervious surface, traffic density, lowest amount of riparian buffer. The greatest concentration was really not after a first rain event. So this wasn't a first flush phenomenon, meaning that it wasn't summertime and you're catching the first fall storm events. There had been previous storms, but we're still seeing concentrations at 500 nanograms per liter. We would expect that could potentially be even higher on a first flush rain events. All the sites are located on an urban gradient, and the concentrations was increasing with impervious surface and traffic. So again, as you move from that upper watershed where you had a riparian buffer, we're seeing higher concentrations as we move down to the more urban locations. The one site I do really want to point out that had very interesting results is this INDO3, the blue site. The blue site was just downstream from a highway outfall that has treatment that seems to capture 6 ppd quinone. So there's a highway outfall that's being discharged into a series of stormwater best management practices, stormwater BMPs. And the treatment train consists of a sedimentation basin, a constructed wetland, and some swales. Those stormwater BMPs, as my understanding, have been installed for quite some time, but you're seeing a pretty significant reduction in 6 ppd quinone. They were able to get an influent concentration, so right out of that highway outfall of 6 ppd quinone, and the concentrations were up to 800 nanograms per liter. Go ahead, Stephanie. You have a question?
So, yes, there's a question in the chat. So Cameron says, does 6 ppd quinone ever break down? What do concentrations look like in our estuaries that are getting constant inputs? Great question, Cameron.
Yeah, so the fate and transport of 6 ppd quinone is still a huge data gap. There's a lot of work going on to understand what the transformation products are. UWT, I believe, is leading some studies on transformation products. So we don't know if it's converting to something else that could potentially be more toxic. At this point, we're still working on getting, a large data set of 6 ppd quinone in receiving waters. We don't have a lot of marine data yet, and we also don't have a sediment methodology. A couple of labs have developed a sediment methodology for sampling 6 ppd quinone in sediment, so that's a big piece of the picture as well, especially for estuaries. But that data is we are starting to get it, as a couple labs have developed SOPs, and I'll go over that in a few slides. We have another question in the chat here. Here, I can actually see him. Looks like there's a few. Oh, I missed if this is stormwater. So this data is actually in the receiving water. This is not stormwater data. All of these slides and the work that Rhea Smith is conducting is receiving water data. So the concentrations are probably lower than what we would see in the direct stormwater. As you can see, they got one sample that was the highway outfall, and that was 800 nanograms per liter. Perfect. Any more questions in there before I move on? Looks like we got it. Okay, next slide, Tanya. So the preliminary results of this initial integrated watershed study, they were trying to determine what correlations would we expect that are going to correlate with concentrations of 6 ppd quinone. Based on Rhea's studies, the stormwater intensity and stormwater duration aren't having a significant impact on 6 ppdq concentrations, meaning that a really intense rainfall and a really long storm aren't leading to higher levels of 6 ppd quinone. The anecdotal dry period and traffic loadings have a moderate correlation, and then impervious surface is having a very strong correlation, which I'll show here in the next slide. Okay, so this is the correlation between percent impervious and traffic means. As you can see, traffic densities, as the traffic density increases along the x-axis, we aren't necessarily seeing higher concentrations of 6 ppd quinone. The red dots indicate observed pre-spawn mortality. So with traffic densities even less than 5,000 counts, we're still seeing observed pre-spawn mortality. But with the increase in pavement, as you get above 25% impervious surface, we're seeing a much stronger correlation in the increases of 6 ppd quinone concentration, as well as observed spawn mortality. So it's really important to know this is data from just one stream, and more streams need to be studied to really understand the fate in transport. There could be a lot of factors impacting this: stream flow, percent impervious surface, a lot of things that could be impacting the data, but it is a really interesting preliminary result. And our environmental assessment program will be doing another round of sampling that's planned for this fall into the spring to get a larger data set and to add to this correlation. So our environmental assessment program and RAO will be kicking off more research starting 2025 through 2027 in this biennium, using some of the funding and other funding sources that Tanya mentioned in her previous slide. They're doing more passive samplers. Oh yeah, I forgot to tell you to skip the slide. Thanks, Tanya. 6 ppd research. We've got more passive sampler surveys being conducted. In addition, they'll be evaluating their effectiveness for studies to determine if passive samplers are really able to correlate with a grab sample or auto sampler as well as we predicted that they can. So in order to do that, they'll be deploying them at more sites and partnering actually with some auto sampler studies for a comparison study, which will be really interesting. They'll be exploring the impacts on wetland species and developing adaptive recommendations on how to minimize exposure. So I believe they're looking at amphibians and stormwater detention ponds to determine their impacts of 6 ppd quinone. They're exploring conveyance of 6 ppdq in stormwater from roads to habitats, a partnership with USGS. And then they'll be evaluating data from the first round of marine and freshwater sediment sampling from this spring. So as I mentioned from that previous question, again, this is a new chemical. Analytical methods are still being developed. We only have a accredited analytical method for 6 ppd quinone in water, but we did several labs, including Tacoma, Manchester Environmental Lab, I believe Eurofins have developed their own SOPs to be able to collect sediment and run it for 6 ppdq analysis. So we're just starting to get that data in. Rhea and her team were able to collect data from marine and freshwater sites, and then they're analyzing that data currently, which will be really interesting. That's data that we haven't been able to assess yet, which is a really big part of understanding the fate and transport of 6 ppd quinone. So next slide. All right, stormwater best management practices. So this is where I spend most of my time, and my work is looking at stormwater best management practices. These are either source control or engineered systems that provide flow control and treatment to stormwater. We have a stormwater manual for the state that has a list of approved stormwater best management practices, and we really wanted to look and see if we had something that's already in our toolkit that's effective at reducing and removing 6 ppd quinone. Next slide. So back in 2022, after the discovery of 6 ppd quinone, the Department of Ecology and many partners got together to do a BMP effectiveness report. The BMP effectiveness report was a literature review looking at existing data, existing literature about what was known physically, chemically about 6 ppd and 6 ppd quinone, and then they used that information to rank the potential of stormwater BMPs from 8 different stormwater manuals across the country to reduce and remove 6 ppd quinone. And then the study also identified a very extensive list of data gaps about things we didn't know about 6 ppd and 6 ppd quinone, which you can imagine a chemical that was only discovered 2 years before. The list was very extensive. So that was, again, a literature review, but it did provide us a list of BMPs. Hey, we think these BMPs might have potential for being effective. This gives us a good starting point on what we should be looking at with our data. So in 2023, we received proviso funding and funding for the legislative to pursue studying stormwater BMPs for their effectiveness. And over the 2 years from 2023 to this past spring, we were able to help fund over 20 research studies. Some of those were standalone research projects. Some of them were partnerships with other ongoing projects where we were able to add 6ppd Q analysis to already occurring projects and their monitoring programs. And we were able to focus in on a certain set of data gaps, even though the list was pretty extensive, but some of the major areas of focus that we wanted to look at, the first one being stormwater characterization. We really need to understand the concentrations of 6-ppd quinone in stormwater so we understand how effective stormwater BMPs have to be at removing it and all of the variables that impact those concentrations, land use, impervious surface, traffic densities. We also wanted to try to test some of the BMPs for effectiveness. Again, the list of potential of BMPs was pretty extensive, but they were all ranked high, medium, and low. So we focusing on these high potential BMPs that included things like street sweeping, which is a great source control BMP that can remove tire wear particles before entering stormwater systems, grassy swales, sorbent medias. 6-ppd quinone is a really sticky compound. It likes to sorb to organics. So anything containing that type of treatment has the potential to be very effective. We also conducted a crumb rubber study looking at crumb rubber mulch and turf field, not as extensive as the study that Tanya mentioned. It's a much smaller study. We sampled crumb rubber from 6 turf fields of varied ages across the Puget Sound area. And then this fall, we'll be collecting the remainder of some stormwater runoff samples from those fields so that we can understand if these turf fields themselves are a source of 6-ppd quinone. And then we still have a lot of unanswered questions about the fate and transport, like the question that was in the chat about, do we know what this is breaking down to? Do we know, the difference between what's sorbing to the sediment and what's in the dissolved phase? We still have a lot of unanswered questions about the fate and transport of 6-ppd quinone. And then we worked on developing some sampling and analytical methods ourselves. Again, this is a chemical that, for me, this is the first contaminant of emerging concern I've ever worked on. So it was really eye-opening to be like, hey, we just can't grab a sample and send it off to any lab. Those analytical methods don't exist. Sampling standing operated procedures don't exist. So we did some method comparisons as well, looking at different types of sampling bottles that you would want to use for sampling 6-ppd quinone. And then we helped develop some sediment SOPs that the city of Tacoma is using. I'll go over here in the next slide. So this is really high level, me cramming 2 years of 20+ research projects into one slide. I could do a whole presentation on all of the things we have learned and discovered, but I wanted to give you guys a quick brief overview, and I have a couple projects I couldn't help myself but not go over. But this QR code right here will take you to our Stormwater BMP effectiveness research page where all of those 20 projects are listed. And again, these are just water qualities projects. It's not all of the work that Ecology is doing, like the product replacement programs that Tanya was talking about, or capturing all of Rhea Smith's and the environmental assessment programs work. It's just within the water quality program and our partnerships, but there's a lot of great information on there, including the QAPs for the projects, project scopes, any final deliverables you can find there, as well as contact information for project leads. So if you have a project on there you have this question about, you can reach out to that person and get more information. But again, a really broad overview of some of our study results. So we did an extensive stormwater characterization study, 2 projects that looked at highway runoff from the I-5 Ship Canal Bridge, and we were seeing concentrations of 6-ppd quinone at around 600 to 700 nanograms per liter. That's coming off from I-5, a high traffic urban area. So that's valuable information letting us know that, treatment from those type of areas, this is the range of 6-ppd quinone that will be dealing with the influent of our BMPs. We also did some mostly lab scale studies on potentially effective BMPs. We were able to do a bioretention and high performance bioretention column study. I'm going to go over that in another slide here, but bioretention known for many years as effective at removing toxicity, but with developed analytical methods, we could actually see the treatment for 6-ppd quinone. We did a granulated activated carbon study with a partnership with Pierce County at their decant facility, which I'll go over here in another minute. Granulated activated carbon, or GAC, is also very effective at removing 6-ppd quinone. We currently have an ongoing unamended soil. This is a lab scale study as well, where they're doing a column test on unamended soils that they don't have any amendments or treatments. It's just native soil taken from forested areas. It does have an organic content that meets some of our specs for infiltration in our stormwater manual. But that unamended soil is also showing to be effective at sorbing 6-ppd quinone. And then there's also a really interesting study run by UWT that you can locate on this webpage. They looked at many components of engineered media. It was a kinetic sorption study. So they looked at soil, sand, zeolites, compost, mulch, to determine what of these components of our engineered soils that we use in BMP are actually sorbing the 6-ppd quinone. And they found that things like biochar, compost, wood mulch, again, things with high organic carbon or high organic content were effective at sorbing 6-ppd quinone, and then granulated activated carbon as well. We also worked with the city of Tacoma to develop their standard operating procedure for 6-ppd quinone and sediment. They have a really large scale study going on that they'll be looking at sediments in different catch basins across the Puget Sound area. So now they'll have a method that they can actually run that analysis. We'll go next slide. The studies for the King County bioretention study is very interesting, and I know that there's been a lot of media out about this study. King County ran this up at Western Washington University, and they tested our standard bioretention mix, which is 60% sand and 40% compost, and our high performance bioretention mix, which removes that compost and replaces it with coco coir and biochar, high carbon wood ash. Compost itself can leach nutrients like phosphorus or metals, so we don't recommend using it within a quarter mile of receiving waters. But the both bioretention medias were very effective at removing 6-ppd quinone, greater than 96% removal. They also did toxicity testing from the effluent of these columns and from the influent. So the untreated stormwater, they saw 0 to 5% survivability in juvenile coho, and the treated, they saw 100% survivability of coho salmon. So very, very promising result. We have testing going on at 2 full-scale bioretention facilities currently to see how this media works on a full scale and under environmental conditions. Thank you. I know we're getting close on time. We just start talking and then just the time ticks away. So I'll go quick over these last ones here. Yes, I see somebody referencing in the chat about the data from Indian Creek. It was Indian Creek, which is a small stream. Yes, you're very right about that. The influent concentrations of 800 nanograms per liter wasn't from Indian Creek. That was from the highway, the stormwater discharge, just to be clear about that. Okay, and to get through my slides, I'll jump back to the questions here at the end. This is the granulated activated carbon study. This was done at a decant facility in Pierce County. They have 3 levels of water treatment for their decanted water: a settling tank, a flocculation tank, and a granulated activated filter. Carbon filter, but you can see they were getting 98% removal from these 3 rounds. So the pre-settling tank, the sediment's going to settle out to the bottom, and then they moves to a flocculation tank where they add a flocculant. It removes even more of the fines. They were getting about 50% removal there, but the granulated activated carbon took the concentrations of 6-ppd quinone down to almost barely detectable levels of 2 nanograms per liter. So very effective at removal, but it's really important to know that GAC does not do well with sediment loading. So one of the reasons this was so effective is that there was 2 rounds of sediment removal from the water prior to emptying the granulated activated carbon filter. All right, next slide. So we're continuing our research. We did get funding for this biennium 2025. We are continuing. Several of these projects will be ongoing, and we'll have more data here in the next few months to share, which is always very exciting. And my favorite part of doing these presentations is sharing the results. But we want to continue doing those efforts. We also want to field test BMPs. A lot of our work in the past biennium was lab scale, but we really need to know how these installed BMPs are working. BMPs can be difficult to sample and monitor because they're not designed designed to do such. Sometimes you can't access the influent or the water is being infiltrated. So there's a lot of challenges around sampling installed BMPs, but we're working with some project partners that we think we should be able to get some good data sets. There's also a lot of things that impact installed BMPs, including maintenance, that really affect their effectiveness. So if something's not been maintained at all, it's likely not going to be as effective as when it's first installed. So we want to take all of those things into account and try to see how these systems are working over their lifetimes. We're going to continue to do stormwater characterization. Again, those influent concentrations are really important for understanding how effective our BMPs need to be. And of course, keep working on the fate and transport aspect of 6-ppd quinone. How is this chemical moving through the environment and how long is it persisting? Next slide. Our major goals for all of this research is to, again, keep synthesizing research and providing information out to all of our regulatory agencies, permittees, and our communities. We want to continue to share our research findings. And our also hope is, do we need to update our stormwater management manual with effective BMPs? So that's always a goal that we're working towards once we have enough data to make those types of decisions. Next slide. So stormwater regulations and rulemaking. This covers our permits a little bit. Next slide. We have our Clean Water Act permits that were reissued. Our municipal stormwater permit and our industrial stormwater permits were issued in 2024. Again, the chemical was discovered in 2020. Usually these permits are drafted a year before they are issued. But the municipal stormwater permit did address reducing project thresholds and retrofits and street sweeping. So essentially providing more treatment for project areas, and incorporated a street sweeping program to try to remove tire wear particles and other materials before entering the stormwater conveyance system. Our industrial stormwater general permit is going to require permittees to monitor and report for 6-ppd quinone starting in 2028. There'll be no standards or limits, it's just reporting. And again, they had to push this back to 2028 because we only have a few limited labs that can actually run 6-ppdq analysis. So hopefully private sector labs and lab capacity will increase by 2028 to support this permit requirements. The WSDOT permit is currently being worked on, the municipal stormwater permit for WSDOT, and they might be incorporating some tire wear particles or 6-ppd components. I'm not sure at this point because, again, we haven't seen it published yet, but we should have an update on that soon. And again, Washington State, next slide, aquatics life toxic criteria. The state of Washington has adopted 12 nanograms per liter as our aquatics life toxic criteria for freshwater acute mortality. Again, that's just freshwater, not saltwater, and also not chronic, just for the acute mortality. But we do have 12 nanograms per liter. It's currently going through the review by EPA. It's been submitted to EPA for review and approval. And of course, there's a lot of stalls and hangups on that moving forward, so we don't have an update on the status of that yet. But currently it's with the Endangered Species Act, Section 7 consultation. And then I think I hand it back to you, Tanya, for the last few minutes here.
We're gonna go, I'm just gonna skip over this guy because we don't have time. The last thing we're gonna leave you with is this. We are hosting a forum in December. It's going to be 4 hours each day, both on December 9th and December 10th. That QR code can bring you to registration. If you are a researcher and you're involved in 6-ppd and would like to be a part of the lightning talk rounds, please fill that out as part of the registration. And we're also offering breakout sessions. And if there's something you would like to lead within a breakout session, you can also note that in your registration as well, and we will reach out to you. It's an effort across with international partners, really. We've got folks coming from New Zealand and Australia and Canada, and all of our federal partners and other state agencies are helping to plan it. So you can learn more there. And there's the email list QR code that I mentioned at the beginning. We send out bi-monthly updates, but also if there is timely stuff like the 6-ppd State of the Science Forum, we will also push information out to that email list. And that's it.
Wonderful. Thank you so much, Tanya and Shelby. That was so informative, and there's just so much to digest. So if anybody has any questions right now, you can drop them in the chat, or you can go ahead and raise your hand and I'll call on you if you have any final questions. We have a few minutes left. See some claps. And also I just dropped in the chat, there is a 6PPDQ research talk by WSU PhD student Nathan Ivy. That's tomorrow at 1 o'clock. I put the registration link in the chat and a few other links as well. Any questions?
Yeah, doing a scan through. It looks like we caught most of them as we were moving through.
Yeah.
Or are there any good resources for public education on 6PPD?
Yes, I can answer that. If you want a basic stormwater course, we have the Thinkific course. There's a link there. So it's not 6PPD focus, but that is something we are kind of thinking about developing. So a basic 6PPDQ class, but we have a stormwater class, so that's available. I don't know, do you have any other resources for that kind of stuff?
Yeah, you know, I was going to recommend the University of Washington grad student who just released her story map. I'm going to drop a link for you in the chat. It was really directed at the public versus the scientific community, and it's really well done. And it's not just 6PPD, 6PPD quinone, but it's very heavily incorporated into the story that she created. And then Cameron, I was going to tell you, I think you had also asked about 6PPD quinone's persistence, which isn't very high, but if you look at that ITRC document that was produced, all the chemical profiling information of both 6PPD and 6PPD quinone are located within that document, which helps to better understand bioaccumulation potential, persistence, etc.
Yeah, the ITRC document is a really great resource.
Well, if there's no other burning questions, oh, there's one in the chat. What is the lifespan of the amended soils?
The amended soils. There's some studies going on. Actually, one just wrapped up, run by Jen McIntyre, who was one of the scientists who first discovered 6PPD quinone, doing a column study of the bioretention media and its effectiveness absorbing 6PPD quinone. We didn't get a great data set for 6PPD quinone, but they ran 12 water years through the bioretention media, and it was still effective at reducing toxicity and removing some contaminants. Like I said, the 6PPDQ data was a little limited because we didn't have analysis when the study started. But the amended soils are something we're still working on. That's why we'd like to also get out into the field and sample installed media, bioretention media, soils, and BMPs to see how effective they are after X number of years of installation and how their maintenance schedules are impacting them as well.
I just
Oh,
dropped
there it is.
the
Thank you.
report. Yep.
Yeah, that's a very interesting study. But again, column scale, environmental conditions and full scale systems do behave differently.
Well, I want to respect everyone's time, so I think we'll wrap it up. But I just want to thank you both so much for coming and talking to us today. I know there's so much interest in this topic. So yeah, we'll just keep doing this kind of, talks and discussions, and hopefully we can have more Q&A in the future. And I look forward to the forum in December.
Thanks, Stephanie. We appreciate it.
Yeah, thank
Please
you
reach
so much,
out
Stephanie.
anytime with questions. We're always available.
We're always happy to talk about this, obviously.
Thank you, everyone.
Everyone.
Thanks. Take care.